proton NMR spectrum. In this section, we'll practice the analyzing the NMR spectrum. So, first of all, begin by inspecting molecular formula. If we have a molecular formula, uh, so first of all, we will focus on hydrogen deficiency index (HDI). If we have a molecular formula, then we will look into HDI. Calculate hydrogen deficiency index. Hydrogen deficiency index will help us how much number of pi bond are present, if there is any ring. So in HDI, normally one pi bond is equal to one ring. Pi bond is equal to one ring. So if we have 4 HDI, means there may be maybe there are 3 pi bond and one ring, and there may be 4 pi bond and maybe 4 rings. So there is a different possibilities. So different possibilities will be arises if we have HDI. When the different possibilities arises from HDI, molecular formula is given, then we will look into pattern of the spectrum. So pattern of the spectrum is here. Spectrum is given. Spectrum of any particular organic compound is given. Identify the structure of a compound with the molecular formula C9H10O that exhibit the following proton NMR spectrum. So we will focus signals and integration. Three things are very important in NMR spectra. Three things are very important. First of all, look at the signals. Signals mean multiplicity. Second, chemical shift value. Chemical shift value represented by sigma delta ppm. So second thing is ppm, and third thing is integration. Third is integration. These three things: integration, signals, and chemical shift value. These three things are very important to interpret NMR spectra. To interpret NMR spectra, focus on three things: integration given in the spectrum, signal given, or chemical shift value. So when we focus these three things, that will be very easy for us to interpret the NMR spectra. And these three things we have already discussed earlier. We, in a detail, we have discussed earlier these three things: integration, multiplicity, signals, and chemical shift value. Now look at the integration. Look at the integration value. Here 21.1, 22.3, 54.1, and 10.2. What is the least value in integration? Least value in integration is 10.2. So divide 10.2. So we will divide 10.2 here. 10.2. So there are 4 integration value. So 10.2 when divided to the whole, that means we will get, if 10 divided by 10, we will get 1 proton. If we divide 54 upon 10.2, we will get almost 5, definitely 5.4 answer. Just we ignore the decimal fraction 0.4, we will get 5 proton. So what about the 21 and 22? If we divide 10, 10, almost how much protons? Almost 2 and 2 protons. 2 and 2 protons. So calculate number of protons. So calculate number of protons. 2 and 2, 4, 5, 9 and 1, 10. How much protons? 10 protons. 10 protons. Now we have calculated number of protons through integration. We have calculated number of protons through integration. In integration, values are given. We divide the least value of integration to the whole integration, and then we now have calculated the number of protons through integration. Now look at the molecular formula. Look at the molecular formula. In molecular formula, there are 10 protons. Yes, there are 10 protons in molecular formula, and we have justified the 10 protons in spectrum through integration. We have justified 10 proton as given in the molecular formula through spectrum by integration. Integration values we have justified. Now we will focus the multiplicity values and focus the multiplicity and signals chemical shift value, because integration we have done the job of integration. So there are triplet at nearing 3.0 ppm. There are two triplet. So there are two triplet, two proton triplet and triplet. For how much integration? Two proton and two protons. Okay. And what about this? What about this? There were five proton. There were five proton having the multiplet, and we have C9H10. We have C9H10. At 10.2, there is a single proton. There is a single proton. This is at 10.2. So definitely these five proton having at 7 above 7 ppm. Definitely these protons are aromatic. These protons are aromatic. Above 7 to 8 ppm, aromatic protons are present. So we know that there are 5 proton at aromatic. 5 proton are for aromatic. And HDI also help us to uh, number of the hydrogen deficiency index for 10 proton. If there is C9H10O is a molecular formula, if we have hydrocarbon for C9, if we have hydrocarbon for C9, that will be C9 and H20. And this proton, this organic compound having H10, having proton 10. So subtract 20 minus 10, 10 and 10 divided by 2, that will means 5. That means 5. Seen that means 5. So 5 is the HDI, hydrogen deficiency index 5. 5 means there may be ring. There may be ring in aromatic system, because multiplicity and signal present at 7 ppm indicate there is aromatic. If there is aromatic, there is aromatic. There is aromatic means 3 pi bond and 1 ring. 4 HDI is completed here. But keep in mind, there is also oxygen. There is also oxygen. Here, CH2, CH2, C double bond O, H. Now 5 proton are for aromatic, and 5 proton, 4 proton CH2, CH2 9, and 1 proton is this. So there are 10 protons. Yes, 10 protons. And the total number of carbon 6 for aromatic, 7, 8, 9. Carbon is C9. Yes, C9. Total number of proton in this organic compound, there are total number of protons 5 proton aromatic, 7, 9 and 10. So there are 10 protons. And oxygen is 1. So C9H10 and O is the molecular formula. So in this structure there is also C9H10O. Two triplet were observed. One triplet for this two proton and one triplet for this two proton. Okay, and one multiplet for aromatic. This is one multiplet for five aromatic. Five aromatic having one multiplet, and one singlet were observed for this aldehyde proton. Aldehydic proton almost observed at 10 ppm. So aldehydic proton almost observed at 10 ppm. So we have four type of signal. One type of signal is for aldehydic proton. Second type of signal is aromatic, five proton having multiplet, and third and fourth type of the signal observed for two triplet. So our compound is justified. Our compound is justified. We have justified the NMR spectrum, and through NMR spectrum we have deduced the structure of organic compound. This is organic compound. Okay, any question you have?
No, I don't have any question.
So in this way we can interpret the NMR spectra. These are the solution given for this organic compound. Divide the integration values, then multiplicity, and then we'll total number of signals, and these different type of signals are joined together. This is a this compound we have at the end. This compound spectrum we have just discussed. Aromatic compound, aromatic system, CH2 and aldehyde at the end. Now 1 2 3 4 5 6 cis spectrum are given. Six spectrum are given, and we have to calculate, we have to interpret and deduce the structures. B part question, I just here to interpret this B spectrum. Remaining spectrum you will try yourself. If you will have any problem, then I will interpret this spectrum. I just here interpret the B part. In a B part, look at the integration value. There is 10.8 and there is 65.7. So least value is 10.8. Divide 10.8 by 10.8. Definitely there will be one. There will be one integration value, one proton. And what's about two? When 10 will be divided, 65 divided by 10, definitely there will be answer will be 6.5, or we can say there will be 6 proton. So one proton and 6 proton. When 1 and 6 proton added, there will be 7 proton. So in molecular formula there are 14 protons. So uh, molecular formula having 14 proton, but we have 7 proton. It means this compound given over here is a symmetrical compound. This compound given over here is a symmetrical compound. How it is a symmetrical compound? Just here, this is if we write, this is our C double bond O, because in molecular formula oxygen is also given. So oxygen almost given means there may be carbonyl, and on both side isopropyl group is given. Isopropyl group is given. Same is the case here. CH, CH3 and CH3. On both side, isopropyl group is given. We have two signals, one doublet and other septet. So here six protons having neighboring one proton. So these six proton will have the doublet. These six proton having the doublet. and this single proton will be having multiplet or septet, multiplet or septet, septet. Same is the case here. These 6 proton having the doublet and 1 proton having the septet, and central position is a carbonyl. So there is a symmetry, there is a symmetry. So we will say that the multiplet and doublet will be overlap with each other. Only 2 signal will be observed instead of the 4 signals, 2 signal from this side and 2 signal from this side, because carbonyl is present on either side. In a carbonyl either side, both pattern of the group are the similar. So only 2 signal will be observed. Doublet and multiplet, only 2 signal will be observed, because there is a symmetry. Instead of the 4, 2 signal will be observed. So this is our structure. Remaining spectrum are assignment for the you, and you can interpret if you have any problem. In next section, I will resolve all the spectrum, and inshallah we will uh, solve this remaining problem. Just I have interpret the B spectrum. Remaining spectrum will be solved in the next session. Okay.
Assalamu alaikum.
Bye.